Hello, hi everyone. Sorry about that. Let's see. Okay, it's working. Here we go. So, as I was saying before, you would rewrite this, or you don't have to rewrite it. I choose to rewrite because it's easier to see the power rule being used here. You take down -3, subtract 1 from -3, which is -4, and then that would be it for that one. Then we have this one over here. So we have -3. Derivative, this is e cosine of x. And then derivative of that is negative sine of x. Camera has like a little parenthesis so we know it's multiplying. And then for this, the derivative of this is -4 times 2x. And now we're going to simplify all of this. So that becomes 15. 15 over x to the power of 4. This became a positive 3 e to the cosine of x times sine of x. And then this becomes minus 8x. Okay? All right. The next one. Well, this one's going to be a bit of a doozy, but we can still very much do it. Constants first. Oh, constants first, -4. For exponents, you just rewrite the exponent, and then you multiply with whatever the chain rule applies here. So that's 10x. Over here, it has a similar vibe where you just write whatever is in ln on the bottom. So it's going to be plus 2, because of 2. 1 over 5x squared plus x. And then the derivative of what's inside here, which is just 10x plus 1. So then you're left with a final answer of negative 40x e to the 5x squared. And then there's not really too much of a way to simplify this one. So I'm kind of just going to write 2 times 10x plus 1 over 5x squared plus x. F prime of x. Okay, over here, this is just going to be, a chain rule. We don't really have to take this apart too much. -2 times 4 times this same expression, but knock down a power, and then the chain of that expression. So 3x squared minus 2. I'm not going to distribute because that's going to be a bit of annoying, but I will just simplify that -2 times 4 to be -8. Okay. And that's going to be your f prime of x. And then the last one. We have this. So that's going to be 2 times 3x to the power of 5 times first the exponent rule, which means we have time to by ln of 3, and then the chain rule. So 5x to the power of 4. And then this guy becomes -5 cosine of x. So here I'm just going to make this a bit prettier. We got 2, or not 2, 2 times 5, which is 10. 10 times ln of 3. And then we'll do 3x to the power of 5, x to the power of 4. And minus 5 cosine of x. Okay. Alright, so hopefully by this point you guys consider yourself masters of derivatives, because what we're going to do next is going to involve a manipulation of derivatives called antiderivatives. Antiderivatives of a function is a function noted with a capital F such that f prime of x is equal to that original function. So the technicality here is that antiderivatives are not unique. They could become unique when provided with constants and constraints from the original formula, but they are not guaranteed to be unique. Okay? If f, capital F, is an antiderivative of f, then f of x plus c, where c is any constant, positive, negative, or zero, is called the constant of integration. So again, f of x is one of many antiderivatives of f of x. And then f of x plus c, where any constant can be positive, negative, or zero, is called the constant of integration. So let's do some technicalities, okay? Let's differentiate x to the power of 3. We know it's going to be 3x squared. Let's do x to the power of 3 plus 10. Well, we know it's going to be 3x squared. The 10 disappeared. What about x to the power of 3 minus 4? That's going to be 3x squared, and then the negative 4 disappeared. What do you notice about all these guys? They are all the exact same. But if you were tasked to go backwards with what basically was what an antiderivative is promoting us to do, you notice that you don't really have a guarantee on what constant was used. So that's why for antiderivatives, which we denote as this indefinite integral symbol, going to be right here, if we take it with respect to x, then you get the antiderivative plus c, where c can just be any constant. And this verbiage is noted as the integral of f of x with respect to x. Actually, wait, I meant to just quote this guy, not the whole thing. Okay. Now, the antiderivative, as you can kind of guess from the context clues, is the opposite of a derivative. So we're going to go in the opposite order that you would a derivative. So for example, for the power rule, we know that derivative of the power rule is just you bring down the power and you subtract 1. Well, the antiderivative of the power rule is that you divide, because we multiply, you divide by 1 of that iteration of that power, and then you rewrite x to be that power plus 1. Think about it like this. If you perform the derivative of this right now, you'll get back xn. So let me repeat that one more time. If I perform the derivative of this guy, xn plus 1 over n plus 1, I get, that's a constant, with n plus 1 multiplying it, and then times x to the power of n. I write n plus 1 because I knocked it down 1. That cancels out, and we're left with xn. And look, that's what it comes out to be. Now, this one does have a pattern, so we're going to go left to right from these, okay? So let's go ahead and do derivative of this. Derivative of this is just 12x negative 4. All right, let me go in order again, just in case. And then, wait, I forgot I said I was going over. Okay, so this becomes this. This becomes this. This becomes negative cosine of x. And then this guy just disappears to be plus 0. So this becomes 12x minus 4 minus cosine of x. Well, what about the antiderivative of that exact same expression? Well, we know that technically, using the antiderivative power rule, this had, if it was 1 before, the step above it was a 2. So we need to take out a 2 and write this as x squared. Over here, notice how when you do the derivative of x times a constant, it just becomes that constant. So if we're just left with a constant, then we just need to put back the x. This one's a bit trickier because you're going backwards instead of cosine. So instead of cosine, recall those derivatives where it just became sine to cosine to negative sine to negative cosine, and then it goes back into sine. You're just going backwards. So we're at negative cosine goes backwards into negative sine. The only thing that needs touching up is this to become 6x squared minus 4x minus sine of x. But for all of these, we have to include a plus c. Because notice how this doesn't exactly match this. The difference was the minus 1. So we know that here the constant would be negative 1. But if we didn't have this information provided to us, then we have to leave room for the negative 1 to appear. That room would just be that plus c. And you're going to do that plus c for all of these integrals. Let's start here. That's 3x, or 3 times e to the x. That's going to become secant squared of x. And then that's going to become negative 6x. And then the derivative of this is just 0. So you're left with the final solution of 3e to the x plus secant squared of x minus 6x is the derivative of that expression. What about the antiderivative? Similarly, you can almost pretend like you're factoring out that constant for these as well. And we know derivative of e dx is e to the x. So the antiderivative, we're going backwards, is also e to the x. So that's going to be 3e to the x. We know the opposite of secant squared is just tangent, so that's the same thing. And then you have 6x, negative 6x. So you know for here that you technically have to write the next power, which is 2. So 1 over 2, x2. And then plus c. This, you can though see, will get simplified. Because 6 divided by 2 is just 3. Alright, there we go. Let's keep going. For here, I'm going to rewrite that as a power just quickly. So that means you get 1 over 2 x negative 1 over 2, which is just 1 over 2 square root of x. And you can see here that it's going to be the exact same thing, but we have to leave room for a constant to appear. Even though there wasn't a constant in this one, you still have to leave room. So like for here, the c would be 0. But again, you can't just assume it will always be 0. Over here, it's definitely going to appear. I'm going to rewrite that power. 4x to the power of negative 3. Then I get 4 times negative 3x. And then you take 1 down, so negative 4. And that becomes negative 12 over x to the power of 4. Here we can see that's the exact same thing. So I'm going to write the exact same thing. 4 over x to the power of 3. But again, the plus c needs to be involved. Okay? If you didn't have this provided, you still could have technically done it the other way using the antiderivative power rule. So you maybe would have taken a beat and you would have been like, okay, negative 12 x to the power of negative 4 dx. You could use the power rule. You would have been like, okay, negative 12 times x to the power of negative 4 plus 1 over negative 4 plus 1. Just copy and pasting that power rule plus c. Here, that bottom part becomes a negative 3, and here this becomes x to the power of negative 3. So that becomes a 4, x to the power of negative 3 plus c, and then you can carry that down. So this one I did cheat a little bit because it's like, oh, pattern. But I realize here that we should still practice the power rule. All right, we got one more iteration. Let's go. So here we got the derivative of this, which is just 2 over x. The derivative of this, which is a negative sine of x. And derivative of that, which is just 0. Here is a bit of a trick question. Not too tricky, but let me explain. So up to this point, we've done the power rule. And I'm going to go ahead and pretend like for this, you do the power rule. So I'm going to rewrite it as 2x to the power of negative 1 minus sine of x, all of which are dx of this integral. Well, let's write it like the power rule. So you do 2x to the power of negative 1 plus 1 divided by negative 1 plus 1. What's the problem with this right away? Before I even keep going, this will be dividing by 0. And that's not correct. So you have to keep that in mind. And we have to remember ln. ln has that unique thing where it becomes just a function of x when you do its derivative. So if you see 1 over a singular x, you have the technical luxury of doing ln. So that just becomes 2 ln of x. And then the opposite of that is a minus, or you can say minus a negative cosine, right? Since we know that what comes from sine is a negative cosine, but you could have also just seen here that we have negative sine jumps to cosine. You could treat it as either one. And this simplifies to 2 ln of x plus cosine of x plus c. So keep that ln trick in mind. We're going to play with this ln trick a bit more in Unit 4. Or actually, you might see it in Calc 2, where you play a lot with this. So keep that integral in mind, okay? All right, that's going to wrap up our lecture. Sorry for the break in between, but they're both going to be relatively short videos, so I hope that's a-okay. All right, again, let me know if you have any questions. Be on the lookout today for the worksheet video and the test 3 review video, okay? All right, again, see you all later. Please email me if you have any questions. Said for like 3 times now. So you know I'm serious. Nah. All right.